Okay, yes, starts our third module, that is basic heat depends on, or basic heat refers with the second law of thermodynamics. As I said, our module based portion is covering like that, right? First module is based on zeroth law of thermodynamics. First module is based on first module based on zeroth law of thermodynamics. Second is based on first law of thermodynamics, and third module, of course, is based on second law of thermodynamics, right? Okay. So before explaining what is second law of thermodynamics, we want to know about the particular lead. What is the particular lead to arrive a conclusion or to express a new law of second law of thermodynamics? From the last session of the first law, from the last session of the first module, I explained that there are suitable, or there are some 4 points of limitations of first law of thermodynamics, right? Limitations of first law of thermodynamics. So the limitations of first law is the key to lead for the formation of the second law. Okay, second law is based on the limitations of the first law. Another main point. Second is based on the limitations of the first law. So uh, before explaining what is second law of thermodynamics, we want to know some points related to some terms, something called a reversible process, irreversible process, heat engine, heat pump, and refrigerator, etc. Etc. terms are there before explaining what is second law of thermodynamics. Okay. So first of all, I want to explain a point called here. In this module, we are dealing with reversible and irreversible process. Right? Reversible and irreversible process. So what is a reversible process? So what are the condition of a material or a particular process to obtain or to relate it with a reversible? ഒരു process reversible ആണെന്ന് പറയാനുള്ള conditions എന്തൊക്കെയാണ്? So what are the conditions of a particular component or a process to be a reversible? Okay, reversible. So reversible simply it means that we can reverse it. We can reverse it. A process which can be ended. The end point and starting point of a particular process is the same. We can call it as a reversible process. Okay, തിരിച്ചു വരാൻ പറ്റുന്ന പ്രോസസ്സിനാണ് റിവേഴ്സിബിൾ പ്രോസസ് എന്ന് പറയാം. So conditions, so there are suitable conditions for obtaining a process to be reversible. First one is it should not involve any type of friction. Frictionless ആയിരിക്കണം. So frictionless. First point is frictionless. The process which undergo a reversible process must be in a condition that it should not involve a friction of any kind. No friction for that particular process. Okay. Second point is the heat transfer should be taking place in a finite temperature difference. Heat transfer from the particular process. ഒരു സ്റ്റേറ്റിലേക്ക് മാറി തിരിച്ചു വരുന്നതാണ് റിവേഴ്സൽ പ്രോസസ്. സോ ഇഫ് ദ പെർട്ടിക്കുലർ പ്രോസസ് is happening in a finite temperature difference, it is called as a reversible process. അങ്ങനെ പറയാൻ പറ്റില്ല, but we can say that a reversible process is a process which can occur only in a finite temperature difference. Okay, finite temperature difference. Finite temperature difference. Okay. And the third point, main point is the energy transfer as heat and work. The energy can be transferred from a particular process or a particular system is a heat and work. Heat, it can be transferred and work can be rejected or absorbed. So energy transfer as heat and work during the forward process. Forward process means it is a reversible process, right? It is reversible. So forward and backward process there. Reversible process happening and a forward process and reversible process there. So the energy transfer as heat and work during the forward process should be identically equal to the energy transfer as heat and work during the reversible process. Okay. അങ്ങനെ മാത്രമേ സീറോ ആവുള്ളൂ. മാഗ്നിറ്റ്യൂഡ് ഓഫ് ദി അങ്ങോട്ട് പോയതിന്റെ ഓപ്പോസിറ്റ് ജസ്റ്റ് വന്നാലേ അതേ പോയിന്റിലേക്ക് എത്തുള്ളൂ. So if in a forward process the energy in the form of heat or work, the energy to transfer in the form of heat and work during the forward process will be identically or should be identically equal to the energy transfer during the reversible process. Okay, energy transferring in forward equal to energy transferring in backward, right? Backward or reversible. Okay. There should be no mixing of fluids. There should be no mixing of fluids. There should be no mixing of fluids. This is the fourth point. There should be no mixing of fluid. There should be a mixing of fluid. If I'm particular, take an example. Let's take a tube type of fluid. Liquid. You can take two types of fluid. That is, one thing is a particular coconut oil, and the other one is a particular water. Then mix it, or some other sunflower oil. The process is that the mixing of a particular process. Okay, mixing of a particular coconut oil and sunflower oil is mixing. We cannot reverse that process. After mixing, can you divide the particular component, a particular mixture into some coconut oil and some sunflower oil mix divide separate illa. So it is not a reversible process. So mixing, there should be no mixing of process. There should be no mixing of fluids. There should be no mixing of fluids between. There should be no mixing of some fluids. ഉണ്ടാകാൻ പാടില്ല, ഉണ്ടാക്കിയാൽ തിരിച്ചു വരില്ല. Reversible condition did not be occur in a particular condition, that mixing of fluids. Okay, so these are the main points related to something reversible process, or we can say that 51 is a quasi-static process. Quasi-static process. Quasi-static. It means that a particular process is happening in a particular process which happens forward or backward, which must be happening in a series of equilibrium steps. Series of equilibrium steps. In a particular point. So it should be happening in a particular series of process, not occurring in a particular sudden process. Not occurring in a sudden process. So it must be occurring in a, it may be happening in a, happens in a quasi-static or a particular series of equilibrium process. Okay, these are the particular condition of a particular component to occur in a reversible condition. So example for a reversible process. Example, we can write an example for a reversible process. Example for a reversible process. What? Call it as boiling of liquid. Boiling of liquid. For example, boiling of liquid. Boiling of liquid. Boiling of liquid occur when a heat is applied to a particular system. The liquid heated and the vapor goes up. So again, when the condensation process occurs, the vapor can be converted to the particular liquid by releasing the heat energy. The vapor can release the particular heat energy and come back to particular liquid state by releasing heat energy. Absorbing heat energy, it can be converted into vapor, and releasing heat energy, it can be converted into what? Liquid state. Liquid state. So if any connection problem occur in our class, please notify me in your WhatsApp. Okay? Please notify me after occurring, if any occurring network issues. So reversible process. So just opposite. Reversible process means the process we cannot reverse it. We cannot reverse it by natural means or by extra force. We can call it a reversible process. Okay. Example for reversible process: mixing of fluids. Mixing of fluids. You can call it mixing of fluids. Combustion of process. Combustion process happening in an automobile. In a bike, combustion process. Can you reverse it? No, we cannot reverse it. So combustion process, mixing of two fluids, etc., etc., or all process occurring in a friction. Friction ഉണ്ടാകുന്ന ഏത് പ്രോസസ്സിലും frictionless process is called as reversible process. So friction ഉണ്ടാകുന്ന ഏത് പ്രോസസ് നമുക്ക് എന്ത് ചെയ്യാം? So we can call a process, any process with occurring friction, called as a reversible process. Example for reversible process: mixing of fluids, combustion process, etc., etc., etc. Mixing of fluids, combustion process. So these are the particular thing for a reversible and irreversible condition. Reversible and irreversible process. So now we want to explain a particular components called heat engine, heat pump, and refrigerator. Okay, heat engine, heat pipe, and refrigerator. So what is a heat engine? Heat engine. What is a heat engine? Heat engine, heat pump, reservoir, etc. are the main particular component in this particular module. In particular module, പഠിക്കുന്ന ഏറ്റവും important points for related to second law of thermodynamics is heat pump, heat engine, etc. 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 Okay. So what is a heat engine? A heat engine is used to produce the maximum work transfer from a given positive heat transfer. So a particular heat engine delivers work by absorbing heat. Heat receive ചെയ്തിട്ട് വർക്ക് തരുന്ന എഞ്ചിനാണ് what is called as heat engine. The heat engine is used for producing maximum work, to produce maximum work using positive amount of heat. Positive amount of heat is what a heat engine. So performance of a heat engine can be calculated by using efficiency. Efficiency എന്ന് പറഞ്ഞിട്ട് വെച്ച് നമുക്ക് കണ്ടുപിടിക്കാം. You can calculate the particular performance. You can evaluate the performance of a heat engine by using the term efficiency. Okay, measure of the success, measure of the performance can be found out by using efficiency of a heat engine. Efficiency of a heat engine can be calculated and can calculate the performance of a heat engine, whether the maximum work is delivered or maximum heat is absorbed or something like that. We can calculate by using efficiency term. Right? Efficiency means the performance of a heat engine. Efficiency means performance of heat engine. We can call it as heat engine. Efficiency equal to W by Q1. W by Q1. This W is work done. Net work done from engine. Net work done. W is called net work done. Net work done. W is net work done from the engine. Like engine delivers the work from the engine. It receives heat and delivers the work or rejects the work. So work done is from the engine. Work done from the engine. So what is Q1? Q1 is the heat absorbed or heat transferred to engine. Heat transfer to engine. Okay, so we can draw a particular diagram of the particular that heat engine like that. Heat engine is a heat engine. A diagram of a heat engine. Heat engine is a particular element or particular engine that receives heat and delivers work. Right? Receives heat and delivers work. So hot reservoir is the hot reservoir. Oh, cold reservoir. Okay. So something Q is the if this work is a hot reservoir, heat is absorbed from cold reservoir, which means heat is absorbed. Heat സ്വീകരിക്കുന്നു. It receives heat from a cold reservoir heat engine and delivers work. Work കൊടുത്തിട്ട് that particular transferred heat is cold reservoir. After work done, additional vital heat cold reservoir. So we can call work done equal to Q1 minus Q2. Work done equal to Q1 minus Q2. Heat engine is a particular type of engine which produces maximum amount of work by absorbing maximum amount of heat. Okay, so heat is absorbed from a cold reservoir and produces work and other releasing work to atmosphere. Hot reservoir work ബാക്കി പുറത്തേക്ക് cold reservoir കൊടുക്കും. That is, we can call W equal to Q1 minus Q2. Q1 minus Q2. We can call has W as Q1 minus Q2. It is a particular heat engine. So a reversible heat engine, very particular heat engine. So we can reverse it. A reversible heat engine can be called as a heat pump. Reversible heat engine can be expressed by two components. That is, one is heat pump and other one is a refrigerator. Heat pump refrigerator എന്ന് പറയുന്നത് heat engine reversible process. Okay, heat engine reversible process ആണ് നമ്മൾ എന്ത് പറയുന്നത്. Heat engine reversible process can be termed by two machines, that is heat pump and a refrigerator. So when a heat engine acts as a when a reversible heat engine acts as a refrigerator, നമ്മൾ എന്താണെന്ന് നോക്കാം. പിന്നെ reversible heat engine acts as a act as a refrigerator. So for the last class, for the last session, or for last module, I explained what is a particular എന്താണ് റിഫ്രിജറേറ്റർ നടക്കുന്നത് ഞാൻ പറഞ്ഞു. അത് ഞാൻ ജസ്റ്റ് ഒന്നും പറഞ്ഞുതരാം. വാട്ട് ഈസ് ഹാപ്പനിങ് ഇൻ അവർ റിഫ്രിജറേറ്റർ. നമ്മൾ വീട്ടിലൊക്കെ ഉപയോഗിക്കുന്ന ഫ്രിഡ്ജ് ഉണ്ട്. സോ വാട്ട് ഈസ് ഹാപ്പനിങ് ഇൻസൈഡ് എ പെർട്ടിക്കുലർ ഫ്രിഡ്ജ്? So there is a evaporator is there. Evaporator, compressor, condenser, and expansion valve. Expansion valve is a particular refrigeration unit. Refrigeration unit on it. Okay. So the flow is happening in a particular direction. This direction. Okay. This direction flow is happening. From a evaporator means something. It's absorb the liquid absorb ചെയ്തിട്ട് അതിനെ evaporate ചെയ്ത് is happening. It is producing a vapor produce converting liquid into vapor. That is happening inside evaporator. Evaporator liquid is converting into vapor. Okay, liquid converting vapor. That vapor travel like this into rise into a compressor. Compressor receives the vapor. Okay, compressor after receive the vapor to deliver the air in a particular high pressure, high temperature, HT, high pressure, high temperature vapor. Right? High temperature, high pressure vapor ആയിട്ടാണ് compressor പുറത്തേക്ക് വരുന്നത്. After entering compressor, the particular vapor convert into high pressure, high temperature vapor and goes into a condenser. Condenser reduces the pressure. Condenser reduces the temperature. Condenser reduces the temperature and gives result high pressure, cold temperature vapor. High pressure, low temperature vapor aside. Okay, high temperature, low pressure vapor. And after expansion it convert into low pressure, low temperature fluid അത് convert. Okay, ഇവിടെ എക്സ്പ്രഷനിലോട്ട് കണ്ടൻസറിലോട്ട് ഫ്ലൂയിഡ് ആണ് മാറുന്നത്. കണ്ടൻസർ ഹാപ്പനിങ് high pressure, low temperature fluid is rejected from the condenser, and expansion out it happens to low temperature, low pressure liquid. And the process happening, the cyclic process. After evaporation, it converts into vapor, and the process is going on. And the cold air is delivered from the evaporator. Evaporator absorbs heat. Evaporator absorbs heat to convert the particular liquid into vapor. It absorbs heat and converting into vapor. For converting a particular liquid into vapor, it wants to absorb heat, right? So heat is absorbed from a particular atmosphere. Atmosphere heat is so heat is extracted from the refrigerator unit. To convert the liquid into vapor. Okay, then heat is absorbed from the surroundings of fridge. So fridge is cooled. So cooling process is happening inside for a unit like evaporator. Cooling is happening evaporator to convert the liquid into vapor, and the process is going for the cyclic process: compressor, condenser, expansion process. This is a particular refrigeration unit. Okay, so അത് ഞാൻ വെറുതെ പറഞ്ഞാണ്. സോ അതിന്റെ ഐഡിയ കിട്ടാൻ വേണ്ടി എന്താണ് ഫ്രിഡ്ജ്, എന്താണ് കണ്ടൻസർ, എന്താണ് ഇവാപ്പറേറ്റർ, എന്താണ് കംപ്രസർ എന്ന് മനസ്സിലാക്കാൻ വേണ്ടിയിട്ട്. ഓക്കെ, ഇതിന് ഒരു വിഷയം തന്നെ പഠിക്കാനുണ്ട്. RAC, റെഫ്രിജറേഷൻ എയർ കണ്ടീഷൻ എന്ന വിഷയം തന്നെ S7 പഠിക്കാനുണ്ട്. സോ here our point is reversible heat engine acts as a refrigeration. Reversible heat engine acts as a refrigerator. That means the figure is like that. Figure just opposites of a heat engine. That is, you can call it as a refrigerator. Okay, refrigerator. And hot reservoir is there. Cold reservoir is there. Okay, cold reservoir is there. Just opposites of a heat pump. That is, so this happen. Q1 and Q2. So for working of a compressor, working of a pump or a refrigerator, we need to apply a work like power want to give to a refrigerator and for a pump to work. So here work is given to a refrigerator. And the refrigerator works and it takes the heat from a cold reservoir and give to hot reservoir. hot ഏതാണോ ഹോട്ട് ആവേണ്ടത് അവിടുന്ന് ഹീറ്റ് എടുത്തിട്ട് കോട്ടിലേക്ക് കൊടുക്കും. That is happening here. In a heat pump or refrigerator, it is happening that work is received. It is a reversible process of a heat engine that it absorbs the work or it receives the work and convert or transfer the heat from a cold reservoir to hot reservoir. Okay. So the work is applied to a particular reservoir. ഇത് തന്നെയാണ് പമ്പിൽ നടക്കുന്നത്. So you can call it refrigeration and pump, refrigerator and pump, heat pump എന്ന് പറയാം. രണ്ടും ഒരേ പ്രോസസ്. Okay. Refrigerator or heat pump. The same figure is applied for a heat pump also. Okay. So we can evaluate. So for reversible heat engine acting as a refrigerator, is a purpose used to achieve the maximum heat transfer from a cold reservoir. To achieve a reversible heat engine as a refrigerator is used to transfer maximum heat from a cold reservoir. Cold reservoir എന്ന് പറയുന്നത് ഹീറ്റ് ട്രാൻസ്ഫർ ചെയ്തിട്ടാകുമ്പോൾ കോൾഡ് ആവുന്നതാണ് കേട്ടോ. So a particular reservoir to convert a maximum heat transfer from a cold reservoir to hot reservoir, we are using heat pump or refrigerator. Okay. The measure for heat engine we use that efficiency to measure the performance of a heat engine, right? For a heat engine we use a particular called efficiency for measuring the performance of a heat engine. For refrigeration and heat pump we are using a term called coefficient of performance, COP. COP, coefficient of performance. Here the performance measure is calculated by using a term called performance is calculated by using a term called COP. Coefficient of performance. അവിടെ എഫിഷ്യൻസിക്ക് പകരം ഇവിടെ COP ഇത്രേ ഉള്ളൂ. റെഫ്രിജറേഷൻ കേസ് COP ആണ് വരുന്നത്. COP means coefficient of performance. As I said, it is a reversible process of a heat engine. Reversible process of a heat engine. So here efficiency is equal to W by Q1. So here we can write it as a COP equal to Q2 by W. Okay. Q2 by W. What is here W equal to net work done or net work done given to particular refrigerator. Refrigeration കൊടുക്കുന്ന വർക്ക്. Okay. W equal to work given to refrigerator. And Q2 equal to heat transfer from cold reservoir. Okay, ഇവിടെ അല്ലേ cold reservoir പുറത്തേക്ക് വന്ന heat absorbed or heat released from a cold reservoir is Q2. That is COP is referred to as Q2 by W for refrigeration. Okay, it is termed as COP എന്ന് പറയുന്നത് for a reversible heat engine acting as a refrigerator എന്ന് പറയുന്നത് that is Q2 by W, that is reversible of particular efficiency. Here it is termed as Q2 is termed as a heat absorbed from a cold reservoir. It is denoted here Q2. W is a work done applied to reservoir refrigerator. Okay. So for a reversible heat engine acting as a heat pump. What is the equation for, or what is the figure is as same as particularly as same as this. Can write here heat pump, refrigerator bar heat pump, cold reservoir Q2, Q1 hot reservoir, W work is giving to a heat pump. Pump work ചെയ്യണമെങ്കിൽ നമ്മൾ വർക്ക് അല്ലെങ്കിൽ പവർ കൊടുക്കണം. Okay. Heat pump or refrigerator. This figure can be noted as heat pump or reservoir refrigerator. So here heat pump is used to deliver maximum heat to heat engine. പമ്പിന്ന് വർക്ക് എടുക്കുക എന്നിട്ട് മാക്സിമം ഹീറ്റ് കോൾഡ് റിസർവോയിലേക്ക് കൊടുക്കുക. ദാറ്റ് ഈസ് ദ ഹീറ്റ് പമ്പ്. വാട്ടർ പമ്പ് ആണെങ്കിൽ എന്താ, വാട്ട് ഈസ് ദ യൂസ് ഓഫ് വാട്ടർ പമ്പ്? വാട്ടർ പമ്പ് ഈസ് ടു മാക്സിമം ഡെലിവർ എ പെർട്ടിക്കുലർ വാട്ടർ ടു എ പെർട്ടിക്കുലർ ഹൈറ്റ്. ഒരു ഹൈറ്റിലേക്ക് മാക്സിമം വർക്ക് എത്തിക്കാനാണ് പമ്പ് റൈറ്റ്. സോ ഹീറ്റ് എഞ്ചിൻ ഈസ് യൂസ് ടു ഡെലിവർ മാക്സിമം ഹീറ്റ് ടു എ പെർട്ടിക്കുലർ heat hot reservoir. So we can write COP here. COP equal to Q1 by W. That is heat transfer to hot reservoir divided by work done. Heat transfer to maximum heat transferred to a hot reservoir to work applied to a particular pump. നമുക്ക് അങ്ങനെ എഴുതാം Q2 equal to Q1 equal to heat rejected to heat rejected or transferred എന്ന് പറയാം. Heat transferred to hot reservoir and W equal to work done. Okay, COP. COP is the term used in the case of for a purpose of measuring the performance of a refrigerator or heat pump. In the case of heat engine, we are using efficiency, right? അപ്പോൾ എന്തൊക്കെയാണെന്നുള്ള ഓർമ്മയുണ്ട്. That is heat engine, heat pump, and reservoir. Heat engine, heat pump, and what is heat pump? Heat engine, heat pump, and heat refrigerator. Okay. We write that term. മൂന്നാം equation എഴുതി. So from the first law, we know that from first law of thermodynamics, we know that W equal to Q1 minus Q2. Q1 minus Q2. Q1 minus Q2. That is heat transfer. Rate of heat transfer is equal to total work done. Total heat transfer equal to total work done. We can call it as a W equal to Q1 minus Q2. W is Q1 minus Q2. So we can write the three equation. Efficiency, COP നമുക്ക് മൂന്നും ആ equation. That is efficiency of a heat engine. Efficiency we can write efficiency of heat engine. Efficiency of heat engine equal to, that is W by Q1. W by Q1, that is Q1 minus Q2 by Q1. Okay. COP of refrigerator, REF, we can write it as Q2 by W1, that is Q2 by Q1 minus Q2. Okay. Then we can write COP of heat pump equal to Q1 divided by Q1 minus Q2. Q1 minus Q2 by Q1, Q2 by Q1 minus Q2, Q1 by Q1 minus Q2. We can write the particular equation of here. Efficiency will be always less than 1, right? Efficiency will be always less than 1, and COP of heat pump is always greater than 1. COP of heat pump always less than 1 ആയിരിക്കും, and COP of. So here നമുക്ക് വേറെ equation എഴുതാം. That is COP of heat pump എന്ന് പറഞ്ഞാൽ COP of heat pump എന്താവും? COP of heat pump is COP of refrigeration plus 1 ആയിരിക്കും. This plus 1 ആയിരിക്കും this. Okay. COP of heat pump equal to COP of refrigeration plus 1 ആയിരിക്കും. അതെങ്ങനെയാണ് നമുക്ക് നോക്കാം. That is Q2 by Q1 minus Q2 ആണോ COP of refrigeration. Q2 by Q1 minus Q2 plus 1. Okay. You can cross multiply ചെയ്ത് കഴിഞ്ഞാൽ you will get Q2 plus Q1 minus Q2 divided by Q1 minus Q2. Then is Q2 and Q2 is cancelled, and the equation will be Q1 by Q1 minus Q2. So that is coefficient of heat pump. So we can write it as COP of heat pump equal to COP of refrigeration plus 1. Okay. So we can surely say that the value of COP of heat pump is always greater than 1. എന്തിനായാലും 1 plus that heat pump ആയിരിക്കും, and that particular value of heat pump, COP of heat pump. So we can surely say that COP of heat pump will be greater than 1 or unit. It will be ഇതിന്റെ plus 1 ആയിരിക്കും. അപ്പോൾ എന്തായാലും plus 1 വരും. Okay. And efficiency of heat engine will be less than 1 ആയിരിക്കും. It is happening ഒരു particular ഇതായിരിക്കും, പെർസെൻറ്റേജിലൊക്കെ കൊടുക്കുന്ന പോലെ. You can write it as 0.8, 0.1 എന്നൊക്കെ പറഞ്ഞിട്ടുണ്ടായിരിക്കും. So that is a particular explanation for heat engine, heat pump, and refrigeration. Efficiency, COP of refrigeration and COP of heat pump. Okay. Want to be thorough with that. Okay. Heat engine, heat pump and refrigerator. Heat engine, heat pump and refrigerator. Okay. Heat engine, heat pump and refrigerator. So next one term you want to study Yes, thermal reservoir and or energy reservoir. What is a reservoir? Reservoir simply means that a huge tank or a huge space to store energy or store heat. Okay, simply reservoir means that it is a particular large space to store a particular heat energy or something. And the store and the space and reservoir. So thermal reservoir means to store a thermal energy or heat energy. Okay, thermal reservoir means thermal reservoir or thermal energy reservoir, TER, thermal energy reservoir, TER. It is used to store a particular, it is a large space. It is a large space to store a huge amount of heat. To store a huge amount of heat. Right? To huge amount of heat. So it can be also called a reservoir of higher heat and lower heat. Small, the amount of heat കുറവായതും. So the value of particular heat amount is higher amount. Okay, so we can നമ്മുടെ source പഠിച്ചിട്ടുണ്ട് അതേപോലെ നമുക്ക് this is a TERH. We can draw a figure like that. Source system sink. Okay, Q1, Q2. So source is a temperature. This is a higher temperature. This is a lower temperature. Okay, TERL and TERH, higher and lower. So TERH is called as TERH, thermal energy reservoir of H means that higher heat energy, or when the thermal reservoir TERH from which Q1 is transferred to system. Q1 is transferred to system is called as source. ഇവിടെ നമ്മൾ ഹീറ്റ് എടുക്കുന്നത് ആ റിസർവർ പറയുന്നതാണ് source. Where the heat is extracted, it can be called as source. Okay, TERH is called source from where the heat is extracted to give സിസ്റ്റത്തിലേക്ക് കൊടുക്കാൻ വേണ്ടി ഹീറ്റ് എവിടെ നിന്ന് എടുക്കുന്നു അവിടെ source എന്ന് പറയും. Okay, and TERL equal to sink, which is that the energy is transferred from or rejected from the system to a reservoir. The TERL is the reservoir. It is called as sink. It is termed as the heat rejected from the source. Q2 എന്നുള്ള ഹീറ്റ് സോഴ്സ് സിസ്റ്റത്തിൽ നിന്ന് ഇവിടെ ഏത് റിസർവറിലേക്ക് പോകുന്നത് ആ റിസീവ് ചെയ്യുന്ന സ്ഥലം, ഹീറ്റ് റിസീവ് ചെയ്യുന്ന ഒരു റിസർവറിനെയാണ് സിങ്ക് എന്ന് പറയുക. ഹീറ്റ് ട്രാൻസ്ഫർ ചെയ്യുന്ന റിസർവറിനെയാണ് വെരി ആസ് സോഴ്സ്. ഓക്കെ, source and sink. Source and sink where heat is transferred to system and heat is received from system. Okay, so for the next class we can explain what is second law of thermodynamics. എന്താണ് second law of thermodynamics അടുത്ത ദിവസം പഠിക്കാൻ. That is what is second law of thermodynamics states that two theories there. One is Kelvin-Planck statement and second one is Clausius statement. Kelvin-Planck statement and Clausius statement is the Kelvin-Planck statement and Clausius statement is the two statements. This law related to two statements. Second law related to two statements, that is Kelvin-Planck statement and Clausius statement. And thereafter you want to study the inequality of Clausius statement or inequality or equivalency of both law. അടുത്ത ക്ലാസ്സിലേക്ക് പഠിക്കാനുള്ളത്. So for next class we can explain about second law of thermodynamics. So this session I used to take a particular area. I want to cover. I covered a particular area of second law before you want to arrive in a complex term. Complex term ലേക്ക് വരുന്ന മുമ്പ് നമ്മൾ എന്താണ് ഈ second law പഠിക്കാൻ പോകുന്നതാണ് ഈ അവർ പറഞ്ഞത്. Okay, right. So we can continue in next class.